Problem number 3. We've got two variables, x and y, and they represent two different numbers between 1 and 100 inclusive. And we're asked to find what the largest value of x minus y over x plus y can have, and what's the largest value that x plus y over x minus y can have. Well, let's first of all take this first statement and write it more mathematically. Alright, so we're told that x is between 1 and 100, so we can write that mathematically as x is less than or equal to 100 and greater than or equal to 1. And we can write a similar statement for y. Y is between 100 and 1. Okay? So now let's look at what x plus y could be. Alright? Because we've got two, we're not dealing with just x and y, we're dealing with x minus y and x plus y. So let's look at x plus y. What's the range on x plus y? Well, the biggest one would be when y is 100 and x is 100, so that would be 200. And the smallest would be when x is 1 and y is 1, so that would be 2. Alright, let's look at x minus y. And before we do that, let's take a look at let's look at negative y. So if y was between 1 and 100, then negative y is going to be between negative 100 and 1. But in this case, the biggest number would be a negative 1, because negative 1 is bigger than negative 100, right? We're just taking the negative of everything. So, this is also the same as multiplying through by a negative 1. So if we multiply everything by a negative 1, you probably know that you have to switch the inequality sign. Okay? Negative 1, negative 100. Okay? But I think this is a little easier to read left to right. Put the smallest number on the left, okay? Which, again, you can tell that the inequality sign, the small end points to the smaller number, and the fat end points to the bigger number, right? So here we got this is saying that negative y is bigger than negative 100. So we're pointing toward the smaller number. Okay, the small end goes toward the smaller number. Negative y and negative 1. Okay, so negative y is between negative 100 and negative 1. Okay, and in this case, negative 100 is smaller, obviously. So, given that, let's see what our range is on x minus y. Okay, so our biggest negative y is negative 1, and our biggest x is 100. Okay, so let's see if we take the biggest thing and subtract the smallest thing, or what should I say, or add the smallest thing. Let's see, not the smallest thing. We have to take the biggest thing and add the biggest thing. We're going to get the biggest thing. In this case, the biggest thing we've got is a negative. Okay, so this is going to be less than or equal to 99. Okay, that's the biggest x minus y we can get, and that's when x is 100 and y is negative 1. Okay, or actually, negative y is negative 1. Y is 1. Okay, so the biggest x minus y we can get is 99. Okay, what's the smallest x minus y that we can get? Actually, probably, I don't know if it matters. Let's see. Essentially, that would be when y is 100 and x is 1, right? So then you'd end up at negative 99. Okay. So that kind of puts some bounds on the things that we're dividing. Okay, and now we're interested in looking at x minus y over x plus y. Now if you think about it, what's the biggest, we have a ratio of two numbers. We want the numerator to be as big as possible, and we would want the denominator to be positive but as small as possible. Okay, and that'll give us the biggest number. Alright, if the numerator is smaller than 0, that meaning it's negative, then it's not going to be, it's not going to be positive anymore. And of course, a negative number is obviously smaller than any positive number. So if we can get a positive number, that's better than any negative we get. So we want the biggest numerator and the smallest denominator that's greater than 0. Okay, but you have to be careful here because this is when x equals 100 and y equals 100. Okay, you can't just say that, well, it looks like if we took well, let's just do that. Let's take 200 is the biggest, sorry, wait, we want to do x minus y first, don't we? So the biggest x minus y we can get is 99, right? And the smallest positive value for x plus y, x plus y is always going to be positive. We want the smallest one, but these x's have to be the same and these y's have to be the same. So really, if we choose x minus y to be 99, then that's when x is equal to 100 and y is equal to 1. Okay, so then x plus y is 101. Alright, so that's choosing the biggest numerator. Now if we look at the smallest denominator, I don't think we can get anything bigger than 99 over 100. So the smallest denominator would be 2, right? X plus y, and that's when x is equal to 1 and y is equal to 1. But then that gives an x minus y of 0, so that's obviously not bigger than 99 over 101. Okay, so that's our answer for the first part, 99 over 101. So the only thing to really be careful of is that you don't look at these ranges on x plus y and x minus y and disregard the fact that the x's and the y's have to be the same. Alright, let's look at this one. Now we have x plus y in the numerator and x minus y in the denominator. We want the biggest numerator. Now in this case it's going to be what? The biggest numerator of x plus y would be 200. That's when x is equal to 100 and y equals 100. But that would give us an x minus y of 0, which that's not going to work. Okay? So we're going to back off a little bit. We need to I guess we're going to assume that these should be integers. Because if they could be fractions, we could back off a little bit and get something, we could probably get a million or a billion or a trillion or a gazillion. Because we could get an x minus y that's just really close together, but not quite there. And so you're almost dividing by, almost dividing by 0. Okay? But so let's assume that they're integers. And so we got to back off a little bit. Let's make them 1 apart. Okay, so that would mean x plus y is 199. So that would be like an x of 100 and a y of 99. And if that's the case, then the denominator would be 1, right? Because the x and the y are just 1 apart. And so that's equal to 199. And that's as big as we can go if we use integers. Okay. Now I can see that I didn't specify integer. So, maybe you can get infinity. Can you get infinity? Essentially, the limit of if we divide by 0, so you get 1 over x, and you take the limit as x goes to 0. All right. So you're sneaking up on 0, taking 1 over x and sneaking up on 0. Well, what's going to happen? This, you could think of it as, okay, dividing by a half, that's going to be 2. Dividing by a third, that's going to be 3. Dividing by 1/100th, that's going to be 100. And so you could divide by 1/1 billionth, and you would get a billion. So, if you could choose any numbers, you could choose in numbers like, let's say, x and y are, let's see, 100 and 99.9999999. Okay, and then x minus y would be 0.000, how many do I have here? 0.002, 1, right? That would be your x minus y. Now that's going to be bigger than 199. But I probably should have said integer here. That's an interesting thought experiment, right? You're always told that you can't divide by 0, but what happens if you sneak up on 0? If you look at the graph of 1 over x, I'm just throwing this in as an aside, you look at what happens if you just sneak up on 0. Now if x is 1, then 1 over x is going to be 1, right? If x is a half, 1 over x is going to be 2. Oops, 2. And if x is, say, a fourth, then 1 over x is going to be 4. Okay, if I put that in there. And you can see, let's see if I can connect these dots reasonably, you get something like this. So as you get closer and closer to 0, your 1 over x, when you divide by 0, becomes essentially infinity. So this is equal to infinity. Alright? So think about what happens if you come at it from the other side. What if you sneak up on 0 from the other side? So you're dealing with negative x's, so if you sneak up on it from the other side, you're essentially going to get the same thing, only it's going to be negative. So if you were to graph 1 over x, you get something that looks like this. So if you sneak up on 0, you can't get to 0 either way, right? If you plug in 0, it just blows up. It goes to positive infinity and negative infinity. So here's negative infinity down here, and here's positive infinity. It just blows up on you. But if you sneak up on it, you can actually get answers. So that's just an aside. Just an interesting thing about dividing by 0. So anyway, there you go. Our original question, the answers are 99 over 101 and 199, and that's assuming that the numbers are integers. So, alright, there you go.